So, real quick, question for you. How we looked at how to evaluate polynomials using synthetic division yesterday, and that was, no big deal. Okay, the other issue though that comes up in this section that I'm going to add to the assignment is this end behavior we started to talk about yesterday. So remind me here, what do we do if I have some big ugly polynomial like this, and I want to take the limit of this polynomial as x approaches positive infinity. First of all, what's that mean? So if I'm going infinitely far out in the positive x direction to the right, what's it asking? What does it mean by the limit of the function? What's it want to know?
How far it goes?
Well, kind of, but we're asking, the f of x stands for y, doesn't it? So we want to know what's the limit of y when x goes out infinitely far to the right. What do you think is going to happen? One of two things is going to happen for a polynomial, isn't it? See it again? It could flatline, but is it going to? We looked at some examples yesterday of polynomials, and what they do is, as we zoomed way out, which is equivalent to going out really far, right? As we zoomed way out, didn't they just get huge? Right? And remember, they either went up or they went down, right? But they did one of those two things. In fact, didn't we look at, we kind of closed up looking at an example where I gave you a polynomial and we sort of color-coded it, remember? And we ended up saying that in the limit as x gets really big in the positive or negative direction, didn't we decide that really that first term was the dominant term and everything else was extinguished? Right? That first one just overruled everything else, right? And all the rest of it just sort of disappeared. So all we really have to do is just look at the leading term to see what the behavior of the function is going to be. And so the question here is, as x approaches positive infinity, what is that first term going to do? 2 times x to the 6th. That's really all we need to answer. So as x approaches infinity, 2x to the 6th approaches what? That's a positive number, isn't it? Right, we're going in the positive x direction, infinitely far. It's a really big positive number. So a positive, very large number to an even power would be what? How would you describe that? What do you think? Haley, looks like you have an idea. It's going to be something like a parabola, you're right. And I don't even need that much, I don't even need you to be that specific, but I just want to know, how would you characterize that number? If I take a really big positive number and I take it to the 6th power, what am I going to get back? What kind of number? Okay, yeah, and so this is going to be positive. It's going to be way bigger, but positive, isn't it? Right? So a really big positive number to an even power remains positive, obviously, right? And it just even gets bigger. So it's a huge positive number times positive 2. Would that change the sign? No. So we get big positive, or we get 2 times a huge positive number is a huge positive number. And what's our mathematical way of saying unlimited, big without limit? Yeah, so it's just going to be positive infinity. See what I'm getting at? Okay. And this, I know this probably seems a little strange to you now. You'll become very familiar with it in coming years. But this idea of a limit is we're just saying, as we go really far out there, what's the tendency, right? The tendency is, as x gets really big in this case, y is going to climb up high, super high without limit. It's going to approach infinity. Infinity is not a number, right? So you can't say, it's not like we're saying as x approaches 8, this approaches 10 or something. It's not like that. This just means as we go infinitely far in the positive direction, this is going to go up and up and up. So the end behavior is going to look like, if I graph this thing, it's going to look like this, right? We don't really know what it's doing in the middle. And this question doesn't care. This question is asking about what's happening way out there, right? So way out there, all we know is that it's going to do that. The the right tail is up. Okay, does that make sense? Okay, what about the left tail? So if we do the same question, only this time we're going to approach the limit of f of x as x approaches negative infinity, what's that going to be? Okay, let's go back, and once again, we just have to look at that first term. Well, what's going to happen there? If we plug in a very, very large negative number to an even power, what's the result? Yeah, any negative number to an even power is positive, right? And so what we're going to get out of this, when we take this limit, it's going to look like 2 times some huge positive number, which is just some huge positive number, right? Does that make sense? Yep.
So you only use the first term in this?
Yes, you do, because, and we didn't get that far yesterday in the fourth period. But third period, we looked at an example where we found that when we graph a polynomial, it's only that first term. When you zoom out far enough, all the other contributions of the other terms just wimp out, and that first one overpowers them all, and it becomes the dominant factor in the polynomial when it gets really, really zoomed out, which is what we're asking about here. So that's the only one you have to consider. Okay? And so we end up with the statement we could make here. This is also going to be positive infinity, or if we write it this way, as x approaches negative infinity, 2x to the 6th approaches positive infinity. So out there, it's going to go up like that, right?
So you'll have 2 answers.
Yeah. Now this one is only asking for the right one, but there might be, a different question. I would ask you a different question that would be a similar polynomial that would be, and we call this an even polynomial because the degree of the polynomial is 6, which is an even number, right? And with the leading coefficient being positive, if we had asked what the limit is as x approaches negative infinity, it also would have been positive infinity because it goes up, right?
So how do you enter that?
In Moodle, well, you would just do this. You'd go into this guy right here, and let's see if I think it's on that menu. Yeah, right there. There's infinity, right? So I would just put infinity for this one. And if I need to, I can put a negative sign in front of it too. Okay? Make sense?
And those are the only 2 answers you get on these?
Yeah. Your answers are always going to be either for a polynomial, if you're exploring the behavior of the tails of the function, polynomials always go up forever or down forever. Right? Let's look at one more quick example, and I think you got it. Okay, I don't need that. Let's get out of there. I don't know how to get out of this. I hit that second pin, and now I can't. Yeah, this is kind of nice, isn't it?
Yeah, our class is like the complete opposite.
Okay, so how about this guy? Let's look at. Let's see. Odd. Less than 0. Let's try that. Okay, what about that one? Can everybody see that? This one's asking for, I can make this a little bigger, I guess. There's f of x. Okay, it wants to know what's the limit of f of x as x approaches negative infinity. Okay? How'd you get that?
Because if you plug negative and you cube it, it'd still be negative. You times that by negative, it's gonna be positive.
Perfect. You see what he's saying?
I agree with that.
Okay, so if we try to evaluate this limit here, it's really just going to be, it's going to end up being the product of -3 times a huge negative number cubed, right? Well, a really big number cubed is really big, but more importantly, a negative number to an odd power is negative, right? So we end up with the result -3 times some huge negative number, which is negative times negative is positive.
So is infinity kind of like an X?
Yeah, I mean, you got to be real careful. I don't mean to imply that you can do algebra with infinity like this. This is just, this is just kind of a way of thinking about it. This isn't strictly the way you would. I mean, I could talk to you for all year about just how to deal with infinity. Infinity it's a huge, no pun intended, it's a huge concept. There's a lot of ways. I mean, you do a lot with it when you take limits. You do a lot with it in higher level math. But for now, really all we're just trying to say is, what I mean by this is just, conceptually speaking, a huge negative number cubed is just some huge negative number. So let's just call it negative infinity, right? Because infinity, it just means a concept. It just means really big, and in this case, big and negative. -3, which is just a small number, but still, a negative number times a negative number is positive, right? And so if I multiply some really big negative number times -3, I still just get a really big number, right? Only it's positive. Okay, so what's telling me then the behavior of the function is, when I graph this thing and I go clear out to the left, it's doing that. Okay? Yeah. Everybody think we got it? For the most part? You can try it out. Okay, so lab time.